Hey guys, now we're going to start on our first lesson. Our question for the day is what if I multiply? And instead of writing this in your math notebook, these are just going to be at the top of every single week's lesson so that we know kind of what our goal is throughout the lesson that we're doing. I'm going to read the introduction and then we are going to get started. Remember that when an object is translated, rotated, or reflected, it stays the same size and shape, even though it moves. For this reason, these types of movements are called rigid transformations. In this lesson, you will explore a new transformation that actually changes how the object looks. What parts of each shape are changing and what parts stay the same? So our goal for today, our big goal, is just to be able to actually change the shape instead of flipping it or rotating it or moving it. And if we move down here, our big question of the day is, how do you think the shape will change when both the x and y coordinates are multiplied by the same number? And it wants you to use the directions below to help solve the problem. So it tells us that it wants us to plot the following points on the graph. So I'm going to highlight this because this is kind of our instruction. It's our main goal for right now. And I want you to remember that when we graph, our points go in this order: x, comma, y. So we're going to connect the points to make a quadrilateral shape, which is just a shape with four sides. And then we're going to take these points and we're just going to plot them right down here. So I'm going to move our graph. Our first point that we're dealing with is 2, 1, which means I'm going to have to find 2 on the x-axis, and then I'm going to go up to 1 on the y-axis. So I'm going to go 1, 2. This point would be 2, 1. And then our next point is going to be 3, 1. So we're going to go on the x-axis again. We're going to go 1, 2, 3. We're going to go up to the 1 on the y. Our next point is 5, 5. So I'm going to go all the way out to the 5 on the x. 1, 2, 3, 4, 5. And then up 5. 1, 2, 3, 4, 5. And then I only have 1 point left. So 2, 5, I'm going to find the x first again. So the 2, 1, 2. And then I'm going to go up to the 5 and put a dot there. And just like our instructions say, they want us to connect the dots so that we have a quadrilateral, which is just a fancy way to say a shape with 1, 2, 3, 4 sides. All right, so now that we've completed A, we are going to flip to the next page and we're going to start on B. So B says without graphing, and this is very important. So I'm going to highlight it. Predict, which means to make an educated guess, how you think the figure would change if the x and y coordinates are multiplied by 2 and then plotted. And so what that means is they want us to look at the graph that we just made, the shape that I just made with the green, and we want to go to every single one of its plot points. And for every number that's an x and for every number that is a y, we are going to multiply by 2, and then for every y, we're going to multiply by 2. So we'll just write in here times 2 and times 2. And that's just to remind ourselves. I'm going to put them in parentheses so that we know that those are multiplication symbols. Okay. And then it asks you to make a prediction without graphing, which means I don't want you to even think about putting any plot points down. I want you to just think about the effects that multiplying each number by 2 would have on the shape. What would it do? I'm not going to write my prediction right now. I'm going to give you some think time so that you do this on your own, and then we're going to come back together and do some more graphing. right, now that you have made your prediction, we're going to test your prediction, and we're going to do that by doubling, which means timesing all the numbers by 2, like I showed you on the last problem before we made a prediction. You're going to times all the coordinates by 2, and then we're going to regraph those new points. And because I don't have a ton of space here, I'm actually going to go to my last page, and I'm going to do my work on that page, and then we're going to plot the new points. Alrighty, here is my last page. You can see the graph here that we have just done. I'm going to do all my work for part C on this page. And so we're going to just write up here so that we know what we're doing. Part C work. And then in order to remind myself as I'm doing this, I'm going to write double the points. I know that we only have 4 points that we're working with here that we're replotting, but as you get into more complicated shapes and whatnot, it can be really useful to write things like this down because you're going to have a lot of plot points to actually multiply in the future. And so sometimes it's helpful just to write down exactly what you're doing so that you remember. And whenever you are changing the shape, we always want to start with these old points, so these original plot points of the original shape. So I'm just going to write here, old, and I'm going to write all the original points that I know, and those are going to be right up here. Those are these guys right here, and so we're just going to write those under the old column right here, and I'm going to slide it back up so we have room to work. Our first point is 2, 1. Our second point is 3, 1. Our third point is 5, 5. And our fourth point is 2, 5. All right, so those are our old points. And remember, we are doubling them, which means that we're multiplying all the x's and all the y's by 2. Okay, so we're going to do this. We're going to write our new points right over here so that we keep track of them in a nice organized fashion. And I like to draw arrows just so I know which goes to which in case you have a smaller amount of space to work with. And I'm going to write times 2. That way, in my head, I go like this. 2 times 2, well, that equals 4. And 2 times 1, that equals 2. Voila, I have my new point. All right, and we're going to do that for every single one. 2 times 3, that would be 6. 2 times 1, that would be 2. 2 times 5, that would be 10. 2 times 5, that would be 10. Times 2 again, and 2 times 2 is going to be 4. 2 times 5 is going to be 10. And for these new plot points, what I'm going to do is I like to be able to differentiate between this original shape and the new shape that I'm about to create. And if you're someone who right now is just working in pencil, then I would recommend doing this especially because you don't have the difference of color to be able to know which shape is which. So I'm going to do a filled in circle here because for my old points, notice how all of these are filled in circles. For this one, for my new shape, I'm going to have every single circle be open. And that's so that I can differentiate between what's old and what's new. So our first point that we have to plot is 4, 2. And remember, the x coordinate always comes first and then the y. So let's find 4 on our x-axis. 1, 2, 3, 4. and then we're going to go up to 2, 1, 2, and remember, open circle. Our next point is 6, 2, so we're going to find the 6 on the x-axis. 1, 2, 3, 4, 5, 6, and then we're going to go up to the 2 again. All right. And then we have 10, 10, so we're going to go over here, find our 10, which is right here, and then we're going to go all the way up to the 10 at the corner. So we have 10 on our x, and we have 10 on our y. And then our very last point that you're going to plot is 4, 10. So we're going to go back to where we find 4. 1, 2, 3, 4. We do our x first. And then we do our y. We go all the way up to 10. Okay. And like I said before, you can use a ruler for connecting these shapes, but you don't have to. Just make sure that if you're not using a ruler, you are making nice lines and you're not being careless. Okay. So that's your new shape. All right, and just like this one, because it has 1, 2, 3, 4 sides, it is a quadrilateral. Now I want you to look at these two, and now I want us to go back to our prediction, and we're going to see how accurate our prediction was. Okay guys, obviously I have gone ahead and put my own prediction down. Now this is kind of cheating because I knew it was going to happen in the first place. My prediction says that I think every side length will double in size and that all angles will stay the same. Now, if you had a prediction that was similar to this, you could say, I think the shape will double, I don't think anything will happen to the shape. Whatever your prediction was, when we move down here, I want you to really think about how you can prove that your prediction was correct. I don't want your answer to just look like this. Yep, you were correct. Congratulations. And the reason that I do not want you to just write something like yes is math is all about proving your ideas and your analogies. And so if you just say yes, anyone can argue with you and be like, well, I don't believe you. So, I don't believe you. Why are you correct? I want you to go back to the two graphs, and I want you to actually tell me, and all of your guys' predictions are going to be different, so I want you to be able to tell me why your prediction specifically was correct. And I'm going to give you a little bit of time to do that on your own, and then we're going to come back together and look and prove my prediction. Okay, so my prediction said that every single side length would double. Now, a really easy way for me to prove this is to just look at the base of each shape. The base of my green shape is 1, correct? It's just 1 cube. Now, if you look at the base of my orange shape, it's 1, 2 cubes. And if you times 1 by 2, or you double 1, you get to 2. Now, that works, and I'm happy about it, but I want to make sure that this isn't the only side length that does it. So let's go over here. This left side length, I'm going to go up 1, 2, 3, 4. If this number is doubled here, technically this should be 8, right? So if I'm correct, this side length should be 8. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I do see that it's 8. You can go ahead and count the rest of these side lengths, but I think it's pretty safe to say at this point that our prediction was correct. So when I go here to finish my prediction statement, I'm going to write yes, just like I did. And then I'm going to write, I know this because each green side length multiplies by 2 or doubles in order to create each orange side length. And if you guys run out of room here, that is totally fine. You don't have to use the lines. All of your predictions, like I said, are probably going to be a little bit different. So if your justification doesn't necessarily look like this, that's okay. But I do want to make sure that you include at least one sentence telling me why, if I were to argue with you, why you are actually correct. So prove me wrong. I'm skeptical, and I want to make sure that you are really right in your ideas. So we are going to move on to the next problem. Okay, so here we have part D, and it says look at the figure you just graphed, which is the orange shape. Transforming a graphed shape by multiplying each coordinate by the same number is called dilation. So we multiplied every single side length on the green shape by 2, or we dilated it by 2, and we got to our orange shape. So I want you guys really quickly for me to tell me a little bit about how the shapes compare. And if you want a little bit more of an in-depth explanation of dilation, you can look at the vocab handout that is in our class, our Google Classroom. So we want to know how the shapes compare, and it wants you to have 3 observations. Okay, so you have to fill out 1, 2, and 3. And the things that I want you to maybe think about in this problem are, I want you to look at the side lengths, compare those. I want you to look at the angles. And I just want you to look at the overall, the general shape. Basically, did it keep its shape? So I'll give you a little bit of time to look over these 3 things as you observe the problems on the graph. I'm going to give you about a minute to look at that and write your own observations, and then we're going to come back together and we are going to write 3 down. In order to make sure that we can look at the shapes here and create observations, I'm actually going to just be writing directly on the graph here. So I'm going to be writing our 3 observations in this space. I would like you guys to write them in the space you are provided, but because I want us to look at these as we talk about the observations, I'm going to be writing them here. Alrighty, the first observation is kind of a simple one. I'm going to start with just the general shape. And when you look at these two, it looks as if you were to take this one and you just zoomed it out, right? We're going to say number 1, the general shape stays the same. Okay, so the general shape stays the same, and I'm sorry, I know that's kind of hard to read, but hopefully you're listening, so you're following along. The next one is also kind of obvious just because it's exactly how we found all of our points, right? The side length of each green side length, each side length doubles, and that's how you get the orange side length. One thing to notice though, even though each side length doubles, the area inside, if you were to take this, it more than doubles to make the area of this, which is kind of interesting to note. So I'm just going to write for number 2. I am going to write that the side lengths, all side lengths, double. And it's really important that all side lengths double, because if we doubled this side length, and this one, and then this one we multiplied by like 4, this line would be way out here, and it would completely change our shape, right? Number 3 is something that I want to introduce to you guys. Number 3 is looking at the angles. Now, when we look at the angles on this shape, we have a right angle here, okay? And you'll notice here you also have a right angle. You have a right angle here, and you also have a right angle here. So far, both angles, the angles of both shapes are similar. Now, if we look here, both of these angles that we see here are less than 90 degrees, okay, which means that we call them acute angles. And these 2 angles here are more than 90 degrees, and so we call them obtuse angles. So both shapes have 2 90-degree angles, 1 obtuse angle, and 1 acute angle. So they match up on all the angles. So I'm going to write here all angles are the same. Okay, and that's really important because if we're looking at how to determine if 2 shapes are similar, a few things have to happen. All the angles absolutely have to be the same. All the side lengths absolutely have to be the same. And the general shape, if these 2 are true, the general shape will always stay the same. Okay? So we're going to move on to our next problem, 6-43, and we're going to look at another graph. We're also going to explore what happens when you multiply by numbers less than 1 and negative numbers. And we're going to do that all and use this as a visual to kind of guide our thinking as we think about these 4 questions in front of us. I'm going to read these 4 questions out loud for you. You guys can just follow along on your own workbook. And then we're going to jumping into the actual calculations that we're going to do to solve these questions. So, the students in Miss Stanley's class were studying what happens to the graph of a shape when all coordinates are multiplied by the same number. They came up with these 4 questions. What happens when each coordinate is multiplied by a half? What changes when the coordinates are multiplied by 1? What happens when both the coordinates are multiplied by -1? And what happens when the coordinates are multiplied by -2? So here we have 4 questions that all are going to make us multiply the 3 points that you see on this shape by a certain number. And here, like I said before, you see that there is a number that is less than 1, a number that is 1, a number that's negative, and another number that's negative. So let's jump into our calculations on the next page and see what we're actually going to be having to do for this problem. A says, for this problem, you are going to have to create 4 different shapes based on the instructions from the questions above. But before you do this, you have to know the coordinates of the original shape, which is the one on the graph that we just saw on the last page of the workbook. And so right now, just like we did in our problem that we just did before with the green and the orange shape, we wrote down the old coordinate points, right? The original plot points. And in the last problem, that was the plot points in our green shape. Well, now it's going to be our plot points that we saw in the triangle on the last page of the workbook. So let's flip back and look and see what those points are going to be. Alrighty, here's our triangle that we are going to be working with today. What I'm going to do is I'm just going to put little dots at each corner. Okay, so that I know what plot points I'm looking for. And really quickly, we're just going to list them out. Remember, whenever you are writing plot points, they are always x first, then y. So let's go to our x-axis, and we're going to find this point first. We're going to go all the way to the 6, and we're going to go down to -4. So our first plot point is going to be 6, -4. And we are going to find the other points for every single other corner of our triangle. Now we're going to look at finding this point right here. Again, I'm going on my x-axis first, and I go to the -2, and then I'm going to go all the way down again to this -4 right here. So the x is -2, the y is -4. So we're going to write it down, -2, -4, and we're going to find our last point now. Alrighty, our last point is the one that's up here on the tippy top of our shape, and it's so high it's almost off of our graph here. But again, we're going to start with our x-axis. We always start with the x-axis first. So we're going to go all the way over here, and it's kind of hard to tell, but this point is at -6 if you were to take kind of a ruler and measure up. This is -6, and then our y would be 8. The B now says, now that you have written down each point of the original shape, you're going to have to change the shape 4 times. Okay. Each time, start with the original points, that's these guys, and then change the shape based on what the question is asking. So remember, there were 4 questions that all asked different things. Some were numbers less than 1, one was 1, and then there were 2 actually negative numbers that we are going to work through. I want you to do all of the work below, and right here, I want you guys to draw each new shape in a different color so that you don't get them mixed up. Now, if you don't have other colors available, I might just, similar to the way that we did our last shapes where we had one be a closed circle and one be an open circle, you might think about maybe doing a star or a triangle for each point, maybe a square, okay? So that with each new shape, the plot points look different so that you can know which shape is which. For Our first question, it asks us to times each number by 0.5 to get our new plot points. But before we do that, we need to write our original points down. And our original points are going to be the same every time. It's these 3 points that we found that are the corners of our triangle. So I'm going to go ahead and write those where it says original points. 6, -4, -2, -4, and -6, 8. All right, so those are our originals. And our instructions are to times each number by 0.5. So that's exactly what we're going to do. It's not set up like our last problem, but the way that I like to do it is I like to just put my finger on a number, multiply it by what I need to, and then write it down. So we're going to do that. 6 times 0.5, that's just a half. 6 times a half is going to be 3. -4 times a half is going to be -2. I got my first plot point down. -2 times 1/2 is going to be -1. -4 times 1/2 is going to be -2. And guys, if you're doing this and you have trouble multiplying by a half, the easiest way to do it is to just take the number and split it in 2. So if I have -6 and I split it in half right down the middle, I know that my number is going to be -3. Same with this 8 here. If you have 8 things and you split them right down the middle, you're going to get 4 on each side. So you're going to write 4 there, and here's your new points. Okay, it's that simple, it's that easy. Now we're going to flip back to our old graph and we're actually going to plot these. Remember, I'm using colors, so I'm not going to be using this system. But if you're not using colors, I would choose one of these shapes right now and I would draw it right here so that you know that those plot points belong to this problem. Alrighty, now that we're back and we have the graph in front of you, I have both papers in front of me, the paper with all of my new plot points and the paper with the graph. But obviously you guys can only see the graph, so when you're doing this problem, I would have both papers available so that you can see what new plot points you have to plot, but you can also draw them on the graph. Our first plot point for the new shape is going to be 3, -2. So I'm going to go to the 3, 1, 2, 3, and then I'm going to go down to -2, 1, 2. I'm going to put my shape right there. My next plot point is -1, -2. So I'm going to go to -1, I'm going to go all the way down to -2. It's okay if you draw on the numbers, it happens, math casualties. Then I'm going to go -3, 4. So I'm going to go 1, 2, 3, that's -3, and I'm going to go up as best I can to about where 4 is. Okay, and I have these lovely dots here. Now I'm going to actually connect them. Again, you can use a ruler if you would like, you do not have to. Okay, and there is my new shape. Once you've drawn it, you have one more step before you're done with question number 1. Your step is to go back to the last page and answer a quick question. Alright, here's our question. How did the figure change? I want you to talk about the side lengths and the angles and the length of the lines. I want you to look at the shape with the pink dots and the shape with the orange dots, and I want you to tell me if there's any similarities, what's different between the two of them. In one to-do statements, I want you to just, in this space right here, Tell me something about the comparison of the two lines, and I'm going to give you about 30 seconds to do that. Alrighty, so we're going to answer this question together. I'm going to write that I noticed that multiplying by 1/2 which is exactly what it told us to do, right? Right up here. That's what we did from purple to orange. I noticed that multiplying by 1/2 made the side lengths only half as long as my original shape. A really basic way to say this, and just as a reminder to yourself, is that if we multiply by less than 1, it actually shrinks. Oops. I can't talk and write at the same time, apparently. It shrinks the shape. Okay, so that's kind of my big takeaway from this one, guys, is that I need to remind myself that if I'm multiplying by 1/2 or anything really less than 1, I'm going to get a shape that is much smaller than my original. We're going to move on to question 2, but in order to start question 2, just like we did here with our original points, we're going to have to rewrite those down. So let's just scooch on down here. And we're going to rewrite our original points. And our original points were 6, -4, -2, -4, and -6, 8. Alrighty. And our job now, question 2 wants us to times each number by 1. Okay, this one will probably be relatively simple. 6 times 1 is going to be 6. -4 times 1 is going to be -4. Remember, guys, everything times 1 is just itself. So any number multiplied by 1, you're going to get the same number. -2 times 1 is going to be -2. -4 times 1 is going to be -4. -6 times 1 is going to be -6. And 1 times 8 is 8. Now, if you look at these, you'll pretty quickly realize the shapes didn't change. These are both the same. And so when we go back to our graph, you're just going to put these neat little blue halos around your original points so that we know, okay, these are repeat points. There's blue points here. We don't necessarily need to replot them. If you want to refine them, you can. But since our points didn't change because we multiplied by 1, we can just stick them here. So the general idea here for our blue shape is that I noticed that multiplying by 1 does not change my shape at all. And the reason that I didn't give you guys think time on this one is this is a pretty self-explanatory one, and we kind of talked about it. But for the other two, I'm going to have you have think time and go through them kind of on your own before we come together as a class. We are halfway done now with this problem, but I want to make sure that we finish strong. So let's go on to the next one. Question number 3 says that it wants us to times each number by -1 to get our new plot points. And we're going to scooch this up here. Our original points, if you flip back to your other workbook page, it's going to be the same ones we always start with. So 6, -4, -2, -4, -6, and 8. All right, those are the ones from our pink shape at the very beginning, our large triangle. And something that I want to remind you of is when we are multiplying or timesing by a negative, you're going to typically have a sign change. And what I mean by that is, for example, let's just look at our 6 really fast. We have a positive 6 right here, and we have a -1. Now, 6 times 1 is just going to be itself. We figured that out on the last problem that we just did with our blue shape. But there's this negative here, which means that this 6 is going to have to change its sign. So it's going to go from a normal 6 to a -6. And if you look at the -4 and you multiply it by 1, you'll get a -4. But if you multiply the -4 by a negative sign, it's going to change the sign as well. So you're going to end up with a +4. Essentially, whenever you multiply, let's use just whatever number, let's say it's x, by a negative, you're going to flip the sign. So let's take our -2, times it by our -1. 2 times 1 is just 2. But since this was negative and we're multiplying it by a negative, we're going to flip the sign, and -2 is going to change to +2. Same with the 4. We're going to multiply the -4 by the -1. The 1 tells us that the 4 will stay the same, and the negative tells us that we have to change this sign. We got to flip it to the opposite sign, and you're going to get a +4. All right, and then our last plot point here, we have a -6. Multiply the 6 by a 1. We know the 6 stays as just number 6. And the negative sign has to get flipped. So we end with a +6. All right. This 8 is going to stay an 8. However, it's multiplied by a negative, which means it has to flip from its sign, which is positive, and it's got to flip to a negative. So here's our new plot points, and these are going to be a little bit different than what we've experienced before with plotting our points, and I'll show you why. Now that we have our graph here in front of us, again, I have my graph here, but over here where you can't see, I have my other workbook page in front of me, so I know exactly what plot points I'm putting on my graph. My first plot point is going to be -6, 4. So I'm going to go all the way to -6, and I'm actually going to go up to 4. So that's going to be about here. Again, if you're not using colors, make sure that this is a different shape than this one, right? This one might be a star, that one might be a square. Just make sure that they look different. Our next point is going to be 2, 4. So I'm going to go X first. 2. I'm going to go up to 4. Put a dot right there. And then I'm going to go 6, -8. So I'm going to find 6 on my x-axis, +6. And I'm going to go down. I'm going to scooch our graph a little bit. I'm going to go down to -8. So right about here. And again, this doesn't have to be exact, but please don't be careless with these dots. All right, make sure that you are trying to put them in the right spot. Then, as always, we are going to, oh, you can see that one already isn't super exact. We are going to connect our dots. I'm going to do the best that I can without a ruler, but there's no guarantees here. Okay. And something interesting just happened. Okay, something a little weird. I know that I can't zoom out too far, but it kind of looks like we just took this triangle and we flopped it. Okay, and what it looks like to me is that it kind of flipped over this line. So when we go back to our analysis questions, let's keep this in mind. All right, let's keep what just happened in mind. The big takeaway here for how did our figure change? What I want you guys to take away from this is that it flips somehow. And I want you on your own to think about exactly how we just flipped that shape. What actually happened? You guys have experience with flipping shapes. We call it reflecting. I want you to take about 30 seconds on your own to finish my sentence for me. What do you notice about the way that we just flipped our green shape? Hopefully you have something written down, some sort of idea. And if your idea matches up with mine, that's awesome. If it doesn't, maybe just add on a little bit as we go through this. One of the things that I noticed is that the shape flipped. Oops. Multiplying by -1 flips the shape 180 degrees. Okay, so it does kind of this full flip, almost like a mirroring. And we can also say, if it flips the shape 180 degrees, it flips over in this case, it flipped over our horizontal axis, the one that goes side to side, which is the x-axis. Okay, but it's still the same shape. So because we multiplied by 1, right, it was a -1, but if we just look at the number and kind of ignore the sign, we multiplied by a 1, which means that the shape is going to stay exactly the same size. When we multiplied by a half, the shape got smaller. If we multiply by something bigger than 1, the shape will probably get bigger. And so the number here we can determine, the number kind of is the deciding factor on if the shape is going to get bigger or smaller. However, the shape can move more than just that. And we just found that out because when you multiply by a negative, we found that it is flipping across the x-axis. All right, so I want you to keep that in mind for this last one, because the last problem, the last question, kind of combines everything into one. All right, this last question, you're going to have to, like we talked about, you're going to combine all of the previous aspects that we've kind of learned about so far when we've plotted our previous shapes. This one wants you to multiply or times each number by -2. All right? And in order to do that, you have to write down your original points, just like we did before. If you have your workbook in front of you, they should be right here. These pink guys, we're always starting with these guys. Okay, we're always starting with the original points, our very first shape that we found. Okay, and now that we have written our original plot points down, we are ready to start multiplying. Alrighty, so we are going to approach multiplying by -2 similar to how we approached multiplying by -1. I'm going to multiply by the 2 on its own first, and then we're going to look at this sign and how we might be able to flip it. All right. 6 times 2 is going to be 12. So I know that it's going to be 12, but I have a negative sign up here, and so I know that I have to flip the sign of this number. And if the sign of this number starts as positive, I have to flip it to negative, so I will have a -12. All right, and then I go to my next number and I have a -4. If I multiply that by 2, just 2, I have -8. But there is a negative in front of the 2, which means I have to flip the sign of my -8 to +8. Then I have 2 times 2, or sorry, -2 times 2, and that would be -4. But again, then I have to include this negative, and I flip the sign, and I get +4. And then I have -4 times 2, and I get -8, but then I have to include the negative, and I flip my sign for the -8 to a +8. Okay, and then I have -6 times 2, and I get -12, but again, I include the negative, which tells me I have to flip the sign, and I come out with a +12. And then I get 8 times 2, which is 16, and I have to flip the sign to -16. Okay, and if it helps you to actually write out all of these multiplication number sentences, feel free to do so. I know there's not a crazy amount of room right here for you to write those, but if you want to take an extra piece of paper and write them out, because mental math is not your thing, then that is totally fine. I want you to use whatever resources you can in order to be able to actually do the math. So if you need some extra practice, you need some extra paper, go ahead and use that. When we look at these points, some of these points go up to -12, 12, and -16. When we look at our graph, it doesn't go down to -16, and it definitely doesn't go up to 12. So what I'm going to do is I'm just going to graph the points that I know that I can. And so again, please have the plot points on one page in front of you and then your graph on the other so that you can look at them and draw at the same time. Our first point is -12, 8. All right, so I am able to, on my x-axis, I can kind of make up where I think -12 might be. I bet you it's somewhere over here. It's a rough science. And then we're going to go up on our y-axis to 8. So we're at, let's say over here, -12 and 8. So we're going to put a point here. It's off the graph. All right, but we're just going to pull out a few points so that we understand what our shape might look like if our graph was big enough to plot it. Our next point is 4, 8. That's definitely a point that we can do. So we're going to go 1, 2, 3, 4 on the x-axis and go up to 8 on the y-axis. And put our point right here. Okay. And then our next point is 12. So we're going to go 12 on the x-axis, probably about here. And we're going to go down -16. Now, if you look here, this is kind of the end of my paper. I have no room to go to 16, okay? So the reason that I made this, and some of you are like, why isn't the graph big enough? That's not fair. I can't graph this last one. Well, let me tell you why. This last one was kind of a check for me to make sure that you understood that multiplying by -2 was not only doubling but flipping the number. If I connect these two lines, okay, this is the base of this first triangle, right? So when we flipped it, the base flipped up here. So the base of our last shape is up here, which means it's flipped. And it doesn't fit on the graph, which means that if you were one of the people that you were like, this carpenter must have made a mistake, because this graph does not fit, or this shape does not fit on the graph, then you are correct, it does not fit, and therefore you know that you are also correct in graphing the shape, because you made it so big, you doubled it, so that it wouldn't fit anymore. So congratulations, if you caught that glitch, well done. I'm going to imagine for a second, I'm going to use my imaginary line here to pretend as if I were to create a giant shape. And I know what some of you are thinking. I'm not just drawing lines. If you notice, I made my lines as parallel to my green lines as possible. And then you're going to have this giant, massive shape that has been flipped 180 degrees, just like our last one, and it's been enlarged. Now I want you to take about 30 seconds to go back to this problem and to answer this question. How did the figure change? I noticed that all right, and you have to fill in the rest. I'm going to give you 30 seconds like I've given you before, Again, this multiplication did two things, and I want you to include those two things. What did it do to the shape? Alrighty, the two things that I noticed that it did to the shape is similar to our last problem, multiplying by -2 flips the shape 180 degrees. And that's the negative part of the number, guys. That's what's flipping the shape. And now it also, I'm going to write an and sign, and enlarges each side length by 2. So similar to our very first problem that we dealt with today, guys, we doubled our points, right? Here we're doubling our points as well, but since it's a -2, we're flipping the shape as well. So remember, when there's a negative sign and a number that's bigger than 1, you're going to be doing two things to the shape, okay? We're going to move on to the last problem of the day. And that would be your analysis questions. And this is your first analysis question interaction. And so I want to remind you guys that because there's a little computer here, that means that you can actually turn this in. You can do that online. But I'm going to read through it and explain it. I'm not going to answer it, but I will explain it so that you guys have a better idea of what you're supposed to be doing. So it asks you to write a conjecture, and it asks you to look at the vocab handout. A conjecture is basically just an educated guess or a almost like a thesis or a hypothesis. It wants you to tell me a concrete idea about what happens to a shape when you multiply its coordinates by any of these numbers. So you have -4, -3, -2, -1, 0, 1, 2, 3, and 4 to choose from. You can choose any of these. So if I were you, whichever one that I wanted to choose, I'd circle it. And so let's just say you circled 1. Now if you circled 1, that falls in the easy category. So if you're someone who's like, you know what, I kind of understand what Ms. Carpenter's talking about, but I'm still a little bit confused, I might choose one of the easier problems. If you understand what we did today and you feel like, you know what, I'm getting more comfortable with this, I could definitely do, you know, the problems that Ms. Carpenter throws at me, I would go for a medium number. And if you want a hard number and you're like, Ms. Carpenter, step aside, I'm taking your job, I could teach this all day long, then choose the hard number. And these kinds of levels will be in other analysis questions as well. So I want you to circle a number within your comfort range, so easy, medium, or hard, and I want you to write your learning log or your analysis questions about it. Once you've chosen the number, obviously I'm not an English teacher, once you have chosen the number that you want to write your learning log about, I want you to write your conjecture. So what's going to happen? If you were to have a shape, right, a triangle or a quadrilateral, and you found all the original points, then you multiplied it by one of these numbers, what would the next shape look like? Down here, after you've written your conjecture, you can actually draw the shape that you had in mind, write your original points, write your new points, and then see if your conjecture up here, okay, your concrete statement, your idea, your hypothesis, let's see if it's correct. All of this can be done online. The only thing that cannot be done online is this guy right here. So if you want to use the workbook to complete the analysis questions and then just turn in the electronic parts that you're able to turn in, that would be perfect. I would recommend that. I think that drawing the shape out onto your graph right here will really help you solidify exactly what's happening to each point when you multiply. If you guys have any questions, please let me know. You guys are doing awesome. I'm excited for what this class holds and what it's going to look like. And I hope that you're all doing well. I miss you guys. Again, if you have questions, just either comment on this video or shoot me an email really quickly. All right. Thanks for watching, guys. Bye-bye.